P-H-Y, 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 P-H-Y. Physics, physics, physics. Welcome!
Hi, Alex. Welcome to another Honors Physics Camp lecture. No, Alex, unfortunately, it's not going to be that type of math. Yes, that's more like it. Today's lecture will consist of additional math skills from algebra and trigonometry that you're going to need in physics. So make sure that you take good notes and let's begin. So let's start by reviewing significant figures. No, Alex, significant figures does not imply that they are VIP digits. It simply means that these digits would make a significant difference if they were omitted from the value. But before we start deciding that, let's first review the four major rules that you must know so that you could determine which are significant figures. First rule states that you should consider all non-zero digits to be significant. So for instance, number 1, there is blank significant figures in 23.83 meters per second because there is blank non-zero digits as described in what rules. So first off, we are going to consider all non-zero digits to be significant. So as we see with this number, there is 1, 2, 3, 4. Four non-zero digits. So that means four non-zero digits as described in what rule? Well, that was rule number 1. So that means that there is a total of 4 significant figures in that value. Okay, so rule number 2, consider all the digits found in between non-zero digits to be significant. So if you have non-zero digits, then that means that any of the numbers that are in between those non-zero digits are going to be considered significant. Doesn't matter if they are actually zeros. So for instance, they're giving us this value here. Well, we know this is non-zero, 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 non-zero. Well, this is my non-zero, and here's another one. So that means that all of the digits in between these are going to be significant. So that would be a total of 1, 2, 3, 4, 5, 6. 6 significant figures because there is how many non-zero digits here? Well, there is 1, 2, 3, 4, 5. There is 5 of them. And how many digits are in between those non-zero digits that we didn't already count? Well, there was one of them right here that's 0. So that means 5 plus that 1, that gives me the total of 6. Now, this is described in rule number 2, as we just mentioned. Rule number 3, consider all the zeros to the left of significant digits to be non-significant. So if we have certain significant figures that we already know, and we look at those and any zeros that are found on the left-hand side of those are going to be non-significant. So for instance, they give us an example here. We know that these are significant figures because of rule number 1, and that is stating that the non-zero digits are going to be significant. Well, I already know that I have 2 of those. So there is 2 non-zero digits. Now, all of these others that are to the left of those non-zero digits, those are going to be actually considered non-significant. So those zeros are going to be considered non-significant. Now, look at what it's asking though. It's saying there is blank significant figures because there is 2 non-zero digits and blank zeros to the right of the non-zero digits as described in this rule. So they're not talking about these zeros. They're talking about any zeros that are to the right. And we don't have any in this case, so that would be 0 of them. So in total, when we're adding the ones that are actually significant, then that would mean there is only 2 significant figures because the ones that are to the left are non-significant. Okay, so this is explained in rule number 3. Okay, rule number 4. Consider all zeros to the right to actually be significant. Okay, so all of the zeros that are to the right of those significant digits are also significant. So let's look at the example. They give you 49.300 kilograms. That's the value. Now we know that the non-zero
digits, those are significant. So I have 3 of them. But then I have 2 zeros. And I know based on rule number 4 that any zeros that are to the right of significant figures, then that means that those are actually going to be significant as well. So it says, and blank zeros to the right of the non-zero digit. So I have 2 of those zeros. So when I add these up, that gives me a total of 5 significant figures for this value. And this is based on rule number 4.
Next, let's talk about scientific notation versus standard notation. Yes, Alex, standard notation is a much more simple way of expressing number values, and scientific notation may seem like a more complicated way that scientists prefer to express those same number values. But you will see that scientific notation is actually very helpful, and it's less complicated than you think when you start using really, really big number values or really, really small number values. Okay, so let's first start by addressing the 4 major steps to convert a standard notation value into a scientific notation value.
Step 1 is where you move the decimal point to the place where only one digit is on the left side of it. Now, for instance, let's say that the decimal point in this number would be moved between which 2 digits when converting to scientific notation? Well, we want to leave only one digit to the left of it. So that means that it would have to be moved all the way over here. So that would be between 2 and 3. Now, step 2 is write times 10 to the right of that value. So I now have the value of 2.30924343 times 10. Now, since the decimal point was moved to the left, in this case, we moved it to the left. So we're going to write it in. Based on step 3, it says that if it was moved to the left, there's going to be a positive sign that's going to be placed on the exponent. So the exponent of 10 will be positive. Now, since the decimal point was moved, let's see, 1, 2, 3, 4, 5 places to the left, the exponent based on step number 4 will now be a positive 5 on that 10. Okay, so when we are looking at the actual value for this, it would read as 2.3 times 10 positive 5. So that would be my actual value. Take a look at scientific notation to standard notation. So the first step is determine the number of places to move the decimal point based on the number expressed as the exponent. So when we are looking at this example in number 1, it's giving us this value. And if we look specifically at the exponent is a 4. It says the value consists of 4 exponent, thus the decimal point will be moved 4 places when converting to standard notation. Okay, step 2. Now I need to determine the direction in which that decimal is going to be moved based on the exponent's positive or negative value. So in this case, we had a positive exponent, which means on this step, on that step, it tells us that if it's positive, you're going to move the decimal to the right. If it's negative, you're going to move it to the left. So since it was positive, I'm going to move this decimal to the right. Now, step 3, move the decimal point in the appropriate direction and the number of spaces by filling empty decimal spaces with zeros. So in this case, I am going to move this decimal 4 times to the right. 1, 2, 3, 4, which ends up being between 7 and 3. Now the value itself is going to read with that new decimal place and by me removing the times 10 expression. So in other words, my value in standard notation is read as Okay, so that would be my actual value, which would be 20,327.3.
Next, let's talk about the metric system and unit conversions. Yes, Alex, I guess that's one way to remember from smallest to larger unit prefixes. Just remember that unit is not an actual prefix. It simply means that there is no prefix present, like saying meters, liters, or seconds, rather than millimeters, milliliters, or milliseconds that do have a prefix known as milli.
So before we start with the actual practice problems, I want you to make sure that you understand how to read this little chart. So in the middle, right here, this would be all of the base units. So it would be, for instance, meters, liters, seconds, and so forth. Now, anything to the left of it are going to be extremely small values, and that's why your exponents here have negative on them. And as you see, 10 to the negative 1 would be represented as 0.1. 10 to the negative 2 would be represented as 0.01, and so forth. Now, anything to the right of those base units of this middle section right here, anything to the right of it is going to be larger values. So that's why our exponents here are positive. So 10 to the 3 would be 1,000, 10 to the 6, and so forth. Those would be larger values. Okay, so now let's take a look at an example here using the following steps. So step 1 says convert the value into a fraction form. Now we can do this by simply dividing it by 1. And then we have to illustrate the units. It's really important that you always illustrate all of the units when you are converting values. Now, number 1 says that you are starting off with a value of 38 kilometers and you want to turn it into meters. Now, first thing, like step 1 says, I have to convert it into a fraction. So I can simply do this by saying 38 kilometers divided by 1. Step 2, I now need to multiply it with another fraction. Now this other fraction is going to be read as the following. The numerator, which is the number at the top, has to have the desired units. So again, let's write down what we have. We have 38 kilometers divided by 1. Now I'm going to multiply it with a new fraction. They're telling me that the numerator, which is the number on the top, has to have the desired units. Well, my desired units in this case are meters. So I'm going to write in meters at the top. The denominator, which is the number at the bottom, has to have the units that I want to eliminate. Okay, step 3. Determine the prefix of the numerator. Express the representing value of that prefix in the denominator. Now, number 3 says the numerator unit is, so in this case, when we're looking at the top value, it was meters, which represents what? Well, remember, meters is not a prefix. Meters is a base unit, meaning no prefix. So when we are writing it in, and it tells you in step 3, if there's no prefix, when we're writing it in the denominator, we would actually be writing it in as a 1. So once again, let's kind of write down everything that we know so far. We know that we have 38 kilometers divided by 1, and we have meters divided by kilometers. And now we know that because my numerator is meters and it has no prefix, it's a base unit, I'm going to write in a 1 in front of kilometers. Okay, step 4 now. So step 4, it says, determine the prefix of the denominator. Express the representing value of that prefix in the numerator. Okay, so now I'm going to say number 4, the denominator unit is, and I know that the denominator unit in this case is kilometers, and it is representing what? Well, if you don't remember what it's representing, you can kind of go back to the chart that we were looking at the beginning and look at kilo. And kilo represents 10 to the 3 or 1,000. I'm just going to represent it by 1,000. Now, when we are writing everything out again, let's review what we know. We know that it is 38 kilometers divided by 1 times meters over kilometers. We know that it is 1 kilometer. And now we know that because my denominator is kilometers and that it represents 1,000, I'm going to write in that value on the numerator value. So this would be now 1,000. Okay, step 5. Solve the equation and eliminate the appropriate units. Now, the initial unit is kilometers, which is the same as the denominator, allowing it to be eliminated, resulting in what units? Well, we're going to result in meters as my final units. When the following equation is solved, the value is converted into what? So once again, let's move all of our values over to that last step. So we have 38 kilometers over 1. We know it's 1,000 meters over 1 kilometer. And as we said, the kilometers can be crossed out. So in reality, all we're doing is we're multiplying 38 times 1,000, 38,000 meters. In this section, we're not going to be actually solving for numbers. In fact, we're going to be looking at only the variable, okay? No real numbers involved right now. We'll input the numbers later. I first need you to understand how to manipulate equations so that they could be equaling the specific variable that it is that you are searching for. So in this case, number 1, we are searching for variable t. So I want you to rearrange this equation so that it could equal t. Now, the first thing that you need to do is identify where is t in the equation and what's going on with it. So in this case, we have t being multiplied by a, and it is also being squared. Now, we'll get to the squared afterwards, but first, let's see how it looks like in this equation. So we said that it's being multiplied by a, but you need to keep in mind that there is also this fraction next to it. So you might not be able to visualize it as well because of the way that it's written out, but this equation can also be written out as at squared over 2. That means the same thing. So the first thing that I would do to get the t by itself is get rid of this 2. Well, because it's being divided, I should multiply by 2 on both sides. So that gives me 2y equals at squared. Now, to get t by itself, I need to get rid of the a. Well, a divided by a gets rid of it. Well, I need to do the same thing that I did on one side to the other. So now I'm left with 2y divided by a. So 2y divided by a equals t squared. Well, I want t by itself completely. So now I need to get rid of the squared. And the opposite of squared would be square root. Whatever I do on one side, I need to do to the other. So in reality, my equation would now be t equals square root 2y over a. And that would be my actual equation. So I want you to box that in. Get used to boxing it in. That way you know that that is your final answer. Okay, so now let's try out number 2. Number 2 is searching for V naught, or also known as V initial. So when we are looking at this equation, notice that that V initial is being multiplied by t. And then you also have the addition of 1/2 at squared. Well, I want V initial by itself. So the first thing that I want to get rid of is what is being added to it. So because all of this is together, I can simply subtract all of that together as a bulk as well. And I'm going to subtract it on both sides. So that would give me, so I'm subtracting it on both sides. So these would cross out, and that would give me x minus 1/2 at squared equals v initial times t. Now, I want to get rid of the t. I want to leave the v initial by itself. Well, because it's being multiplied, I need to divide on both sides. Okay, now I'm going to be left with v initial equals x minus 1/2 at squared over t. And that would be my answer.
Okay, Alex, your favorite section is next, which is a short review of trigonometry. Yes, that's right, Alex. We're going to be using SOHCAHTOA for this next section.
Because that's how you're going to remember what the actual formulas for each sine, cosine, and tangent are. So sine, you have SO, which is opposite over hypotenuse. Cosine, which is ka, you have adjacent over hypotenuse. And then toa, which is opposite over adjacent. And you need to remember that. It's going to be very helpful when we move on to the next units of physics. Now, when we get to the next parts, when we're talking about vector components, that is when we will discuss where you also use y over resultant, x over resultant, and y over x. And we'll discuss that in greater detail later on. But I wanted you guys to just kind of start remembering about that. Okay, so now let's take a look at the first problem that they give us. So the first problem says solve for x. X, which is a side of the triangle. Notice how they're giving you the hypotenuse and you have the other side of the triangle. So in reality, you can solve for this using the a squared plus b squared equals c squared formula. Now you can use either the method that we talked about in the previous section, which was solving for the variable first and then inputting the actual values, or you can just input the values and solve for the missing variable. It's up to you, whatever makes it easier. So for instance, let's say that I have c, which is 30 squared, equals b squared, I don't know it, plus a squared, which is 18.88, and that's squared. 30 squared would be 900, and I just kind of bring everything else down. Now let me solve for 18.88 squared, and that gives me 356.45 plus b squared equals 900. Well, now I need to get rid of the 356.45, move it to the other side so that b can be by itself. So I need to subtract it on both sides. And when I do that, that gives me 543.54. Okay, now I need to do the square root of that value. Okay, so the square root of 543.54 would be 23. So I need to square root everything. So that would be b equals 23.3 meters. And that would be my answer. Number 2 states solve for x. So they're giving me this unknown. I know my hypotenuse, but I don't know the y, which is the other side of the triangle. But I do have a angle. Okay, and if you remember from what we talked about with SOHCAHTOA, okay, you need to remember which ones are the opposite, adjacent, and hypotenuse. So the hypotenuse we know is this one, the longer side, okay?
Opposite means that it's opposite to the angle.
Adjacent means that it's the side that is next to the angle. So this would be adjacent. And because I am solving for x, which is labeled as adjacent, then that means that thinking of SOHCAHTOA, that means that I would be using this one right here. Okay, because that's the one that's involving adjacent and hypotenuse. So that would be cosine theta equals adjacent over hypotenuse. Well, I know that my theta in this case is this angle, so that's cosine 35 equals, my adjacent would be the unknown x, the hypotenuse would be 10. Okay, so now I solve for x. So the first thing that you need to do using your calculator, make sure that you do have it in degree mode. Okay, you would first figure out what is cosine 35. So the cosine of 35 in degrees on the calculator would give you a value of 0.81. So I'm going to write it in as 0.81 equals x over 10. Now I need to get rid of the 10. So I'm going to multiply by 10 on both sides. That gives me x equals 8.1 meters, and that would be my answer.
This concludes our math review. Make sure that you study, and that's it. Have a great one.